Welcome back. Today, we're diving into an explainer on one of the absolute most spectacular locations on Earth, the Great Barrier Reef. But we aren't just looking at it as some beautiful tourist hotspot today. We're going to examine it as this hyper-vibrant, neon-colored underwater metropolis. It's a bustling city of life, and right now, it is fighting for its very survival against a compounding alliance of threats. It's basically a perfect storm of environmental pressures. But as you'll see, there's a really fierce fight underway to build back its resilience.
So let's jump right into our roadmap for today. We'll be covering a vibrant metropolis, the heat of bleaching, toxic runoff, the starfish predator, the tourism paradox, and finally, building resilience.
Section 1, a vibrant underwater metropolis. Before we can even really talk about the threats, we've got to establish what's actually at stake here.
To put things into perspective, this living masterpiece stretches an astonishing 2,300 kilometers along Australia's northeastern coast. That is roughly the distance from Vancouver all the way down to San Diego. It's literally so massive, you can see it from space. And actually, it's not just a single reef. It's this sprawling, highly interconnected network.
The biodiversity here is just staggering. We're talking about a megacity made up of 3,000 individual reefs. It provides this incredibly intricate home for 400 different species of coral, 1,500 species of fish, plus sea turtles, dolphins, and dugongs. It's a finely tuned machine, you know? Every single organism plays a crucial role.
Moving to Section 2, the heat of coral bleaching. This is where we get into the overarching existential threat to this vibrant world. Rising ocean temperatures and that terrifying ghost white phenomenon. So what's actually happening during a bleaching event? Well, corals have this beautiful symbiotic partnership with microscopic algae called zooxanthellae. These algae live right inside their tissues and give them those eye-popping neon colors. But when the coral gets stressed by heat, it panics and expels these algae. What's left is just translucent tissue over a stark white skeleton. The coral isn't dead immediately, but structurally it's compromised. Functionally, it's starving to death.
And, it really doesn't take much to trigger this. Imagine running a constant low-grade fever for a solid month. That's exactly what a single degree Celsius rise above the seasonal average does here. Just 4 weeks of that is enough to cause severe stress and trigger a mass bleaching event.
The acceleration of this threat is frankly terrifying. Mass bleaching used to be historically rare. The first one on record wasn't until 1998. But fast forward to 2016, and a marine heatwave wiped out 29% of the reef's corals. Since then, the recovery windows have basically slammed shut. We had back-to-back events in 2017, and right now, in 2025, the reef is suffering its sixth mass bleaching just since 2016.
Which brings us to Section 3, toxic runoff and sedimentation. Because while the heat is an assault from the changing climate, there's a massive land-based assault happening at the exact same time. Get this, over 90% of the pollution washing into the Great Barrier Reef comes directly from agricultural farm runoff. 80% of the land right next to the reef is used for farming, things like major beef cattle grazing and intensive sugarcane cropping. So when tropical floods hit, eroded soil and agricultural chemicals wash straight out into those coastal waters.
The excess nitrogen from all those fertilizers acts like a dark, suffocating cloud. It sparks harmful algal blooms that dramatically drop water clarity. This literally blocks the vital sunlight that corals and seagrasses desperately need to survive. It lowers their immune systems, making them way more vulnerable to bleaching and disease.
Section 4, the Crown-of-Thorns predator. Beyond invisible heat and chemical runoff, the reef also faces a very real, very tangible monster.
Okay, so the crucial nuance here is that these crown-of-thorns starfish are actually a natural part of the ecosystem. In normal numbers, they're helpful. They eat fast-growing corals, which gives the slower-growing species a chance to catch up. It keeps the diversity balanced. But when they hit outbreak proportions, which, by the way, is often fueled by that exact same poor water quality we just talked about, they are disastrous. They absolutely decimate the coral. So what do? We send in underwater medics. There's this incredible, highly targeted manual control program where specially trained divers locate an outbreak and individually inject the starfish. They use a naturally occurring bile salt, which is bizarrely enough made from ox liver or just vinegar. It neutralizes the starfish completely without harming the surrounding ecosystem at all.
Section 5. The paradox of tourism.
Millions of people travel from all over the world to see this wonder, and that creates a really complex, double-edged sword. On the one hand, tourism is a massive economic engine. It supports tens of thousands of jobs and directly funds active restoration projects and marine education. But look at the flip side. The sheer volume of visitors leads to over-tourism. You get dropped anchors, accidental kicks from snorkelers, sewage discharge. All of it contributes to physical damage and pollution, which just amplifies the stress this environment is already under.
Section 6. Building resilience and fighting back. With compounding threats from heat, runoff, starfish, and human traffic, where do we go from here? Let's pivot and look at the innovative fight to save this ecosystem.
One absolutely massive, foundational success story is the Great Barrier Reef Marine Park Zoning Plan. Introduced over 2 decades ago in 2004, this plan drastically increased the highly protected, no-take green zones from just 5% to a whopping 33% of the reef. It literally set the global benchmark for marine conservation. And you know what? The science backs it up entirely. As Josh Thomas, the CEO of the Reef Authority, points out, these protected green zones are demonstrably more resistant to environmental impacts. When a cyclone or a bleaching event hits, the communities inside these no-take zones recover significantly faster than the ones outside. If we give nature a safe haven, it can heal itself. But traditional conservation just isn't cutting it alone anymore. Scientists are looking to the future to buy the reef some precious time. We're seeing tests of some wild, futuristic technologies, like marine cloud brightening. They literally spray microscopic seawater droplets into the air to create an artificial fog. It thickens the clouds to reflect solar energy away from the ocean, effectively creating a cooling shade to protect the corals during extreme heat waves. How cool is that? Which brings us to our final thought for today. We are looking at an ecosystem pushed to its absolute limits, but it is fighting back with everything it has. We have proven solutions working in the water right now, from huge zoning protections to those targeted diver interventions to bold new climate tech. The question isn't whether we can help the reef recover. It's how quickly and how broadly humanity is going to scale these efforts up to secure a vibrant future for the Great Barrier Reef. It's literally a race against the thermometer, and the whole world is watching.